In this section, we have to use the graph to find the rise, run, and slope. Then we have to write the equation of the line in the standard form ax plus by equals c. You can see this graph connects 2 points for us using the horizontal distance of the x-axis and the vertical distance of the y-axis. If we think about it in terms of rise and run, to go from this point to this point, our rise is actually negative because we would have to go down. So if we count, the rise would be 1, 2, 3 units down, which would be a -3. The run then would be the distance that we would have to go horizontally, which again would be negative because we're going in the negative direction. We would have to go 1, 2, 3, 4, 5 units in the negative direction. So our run in this case is -5. So if I want to write it in terms of rise, my rise is -3, my run is -5. Since the slope is a ratio of rise to run, my slope would be my rise, which is -3, over my run, which is -5, which a negative over a negative simplifies to a positive. So my slope is +3/5. To write the equation of the line in standard form, I need to locate at least one point on that line. I will look where the line passes through a point that's on the grid. So we'll say this point right here. That would be the point, if I start at the origin, -1, 2, 3, comma, -1. So I know that this line passes through the point -3, -1. I also know that the slope is 3/5. So if I use the equation y equals mx plus b, I know the x and y coordinates of my point are -3 and -1. I can fill those in for x and y. I know the slope is 3/5, so I can fill that in for m. That would give me -1 equals 3/5 for m times -3 for x plus b. This gives me -1 equals -9/5 plus b. If I add that 9/5 to both sides, this gives me that the y-intercept, or b, is 4/5. So the equation of my line, I'm going to make this a little bit smaller so that I have some more room. The equation of my line then is y equals 3/5 x plus 4/5. To get this into standard form, I have to move the x term to the other side, so I can subtract the 3/5 x from both sides, which leaves me with -3/5 x plus y equals 4/5. I have to clear the fractions because I can't have fractions in standard form, so that means multiplying every term, or multiplying the entire equation, by 5 to clear those fractions. That gives me, if I come up here, -3x plus 5y equals 4. And the last thing that I would need to do to have it in standard form is to clear the negative with the leading term, so I need to change all the signs. I'm left with 3x minus 5y equals -4. Number 11 is the same idea. I have to find the rise, the run, and the slope. So I'll need a rise, a run, and a slope. My rise is the vertical distance, so since I'm going from this point to this point, I'm moving up 1, 2, 3 units. So my rise will be a +3. My run is the horizontal distance, which in this case is negative, because I'm moving in the negative direction, so that will be -1, 2, 3, 4, 5. So my run is a -5. Because slope is a ratio of rise to run, my slope will be 3 over -5. When you write a fraction, it's usually customary to put the negative with the numerator. So my slope is -3/5. To write the equation in standard form, I need a point that the line passes through. There's an infinite number to choose from, but I will kind of focus on one that the line passes through those integers that I can kind of look at. So we will focus on this point right here, which is -4, +2. I'll start with slope-intercept form, which is y equals mx plus b. I know the x and y coordinates of the point I found, and I know my slope. I can plug all of that information in to get 2 equals -3/5 times x, which is -4, plus b. So this gives me 2 equals +12/5 plus b. If I subtract the 12/5 from both sides, let's see, that would be 10/5 minus 12/5, so that's -2/5 equals b, which you can see is about right. The y-axis, or the graph crosses the y-axis at about -2/5. Let's see, let's make all of this a little bit smaller, just so we have some more room here. So my equation in slope-intercept form is y equals -3/5 x minus 2/5. To get this to be in standard form, I would add that 3/5 x to both sides. So that gives me +3/5 x plus y equals -2/5. I have to clear the fractions. They both have denominators of 5, so I'll multiply each term by 5. That leaves me with 3x plus 5y equals -2. This time the leading term is already positive. I cleared the fractions. Everything's in the right order. So this is standard form. For this graph, I'm asked to use the graph to find the x-intercept, the y-intercept, and the slope, and then I'm asked to write the equation of the line in slope-intercept form. Well, the x-intercept is just the point where the graph crosses the x-axis, so that would be right here. So my x-intercept, which is located right here, would be the point -2, 0. Okay, so that x-intercept is at -2, 0. The y-intercept is the point where the graph crosses the y-axis, so that's down here, which is the point 0, -4. To find my slope, I have a couple of options. I can either plug these numbers into the slope formula, or I could use the idea that slope is rise over run. So my slope is just going to be a ratio of the rise and the run to get from one point to another. So if I use my intercept points, my rise to go from this point to this point, I would have to go down. So my rise is negative. My rise is -1, 2, 3, 4. So the rise portion, or the numerator portion of my slope, is -4. After I go down -4, I would have to go over 2 in the positive direction. So my run would be a +2. If I simplify, -4 divided by 2 gives me a slope of -2. So my x-intercept is -2, 0, my y-intercept is 0, -4, and my slope is -2. If I want to write the equation in slope-intercept form, which is y equals mx plus b, all I need to know is the slope and y-intercept. I already have that information. I know that the y-intercept is 0, -4, which means that I would plug in -4 into the equation. I know that the slope is -2. If I put it all together, that gives me y equals -2x plus a -4, which is the same as -4.